Problem 4 asks for the total flux through this particular geometry right here. So what do you have? Downwards magnetic field, 2 Tesla in strength in this half. Upwards magnetic field, 1 Tesla in strength through this other half over here. What's the total flux? Well, the definition of the flux is always going to be the same here. This capital Phi is always B times the area. But you have 2 different B's in 2 different areas, so no reason why you couldn't say B1A1 plus B2A2 to separate them, because you have 2 different regions in this problem. Often you only have 1 region, but in this case you have 2 here, so no reason why you can't separate it. So being a little bit careful with the signs then, if I sort of assume for this problem here that the normal is up, let's just say that the normal to this area is straight up out of the page here, I have a downwards magnetic field, so that's going to generate a minus sign, because technically this flux here is BA times the cosine of theta, where theta is the angle between the magnetic field and the normal to the area. So in this case, they are opposite in this case. So this will be a minus 2 Tesla times the area of this square part right here. That's easy to calculate. We'll wrap it up at the end, but for now, that's the core physics in there. The minus sign is important because of the difference between the normal and the area in there. Now you have the B2 in here, which is going to be the 1 Tesla. That's in this other half over here. And this is going to be a positive sign because the normal to this area is up and the magnetic field is also up. That's a cosine of 0 giving a positive number times the A2 in here. And so I think the problem basically can solve itself now, because it looks like A1 and A2 are actually the same. The areas are actually the same here, to just be something like the 0.2 squared. Where did I get that from? That's just base times height of a rectangle right there. Some very simple geometry in there. So if you take these 2 areas here and plug into that A1 and that A1 right there, you won't get 0. It isn't like this is a negative quantity plus an identical positive quantity, because the magnetic field is twice as large over there. So you will get a net negative flux in this particular problem here. Shouldn't be a huge thing, but that's the way the problem would work out then. So you will sort of get some net magnetic flux in this thing here, which is going to be less than 0 just by adding the 2 terms together. Might make sense. You have more of a downwards flowing field here because it's twice the magnitude of the upwards going one. So there is a net flux downwards out of this area right here. So you can just go ahead and compute that and get the flux.